welcome to this session. In this session, we will discuss the solution of KVPY. So this examination was conducted for 12th class in 2015. So let us start. The Lewis acid strength of BBr3, BCl3 and the BF3 is in the order. So this order is given: BBr3, BCl3 and BF3, boron trifluoride. So out of these three acids, it will be answered by using the concept of back bonding. So in back bonding, BF3 is this is more acidic than this one, BCl3 and BF3. So stronger the back bonding, weaker is the tendency to act as a Lewis acid. So there is a strong bonding in BF3 because it has 2p orbitals, and the electron from the orbital from the 2p is back bonded with the fluorine. So p orbital is back bonding with the electron deficient boron. Similarly, the 3p will be bonded with the 2p, but since 3p is large and 2p is more, so this will be less acidic. This will be less acidic or weaker acid. And similarly, there will be again bonding of 4p to 2p. So again 4p is more bigger orbital. So again this will be more overlapping with the boron. So this is more overlapping. So this will be your weaker acid, while the BBr acid will be your strong acid. Stronger the back bonding, weaker is the tendency to act as the Lewis acid. So which is more acidic? Acidic will be BF3, BCl3. So this is more acidic in nature. Now O2 minus is isoelectronic. With isoelectronic means they have same number of electrons. So oxygen atomic number is 8, so 8 plus 2 is 10 electrons. So the zinc has atomic number is 30, so it has 28 electrons, 28, and this will having 12 minus 2, that is 10 electrons, and potassium having a 19, so 19 minus 1, 18 electron. And this is a nickel, so nickel is your again 28, so 28 minus 2, again it has 26 electrons. So which is isoelectronic, since oxygen have 10 electrons and magnesium have 10 electrons. So answer B is correct answer. So this is only correct. So these are the molecules HCH, HNH and HOH. So bond angles in methane, ammonia and water are respectively or close to. So to find the bonding, we have to draw the structures. So if you draw the structure of the methane will be like this. So this will go under tetrahedral without any lone pair. So bond angle will be 109. And ammonia have one lone pair, so it is making some lesser angle than this one, than of methane, so it is 107, while it has two lone pairs, so again bond angle will decrease. And this bond angle decrease because they are following the VS-EPR theory, that is the valence electron pair theory, in which lone pair bond pair is more and bond pair is less. So greater the number of lone pair, smaller is the bond angle, if the hybridization of central atom is almost same. So in this case bond angle is more, and in this case bond angle will be less. So answer is our B answer. In alkaline medium, the reaction of hydrogen peroxide with potassium permanganate produces a compound in which the oxygen state of manganese is. We have four options. So to understand, we have to see the reaction. This is the reaction. This is the potassium permanganate reacting with the hydrogen peroxide. So it is converting into this one MnO2, H2 and O2. So oxygen state of Mn in Mn2 is plus 4. So this will be plus 4. So answer is our D. The rate constant of a chemical reaction at a very high temperature. The temperature is very high and it will approach. So we have four options: Arrhenius frequency factor divided by the ideal gas constant, activation energy, this, and activation energy divided by the ideal gas constant. So first we'll just see the theory. So ideal gas constant nothing but the rate constant equal to Arrhenius factor into e to the power minus Ea by RT. So now this temperature is the denominator. Since this is very high, this temperature is very high, so the whole value will, at high temperature, the whole value will come to e to the power naught. So this is nothing but the 1. In this case, rate constant is equal to Arrhenius factor. So answer is our C. Arrhenius frequency factor is constant. The external reduction potential of in volt of a few metal ions and non-metals are given below. This is the reducing strength of the metals. So we can see A option, B option, C and D. So out of these options, which have reducing strength, so the element which have the low value of ion reduction potential is a good reducing agent. So in this, which have a good low value reduction potential, chromium is lower, then lead, then copper and silver. So answer will be your, so this answer B is your correct answer. Which of the following molecules can exhibit the optical activity? So 1 bromopropane, 1 2 bromobutane, and 1 bromopentane, and bromocyclohexane. So if you draw the structure, 1 bromopropane each. This is the bromopropane, okay, and the bromobutane means this is the butane, and this is the bromine. And again 3 bromopentane. So 3 bromopentane will be, if you draw the structure, 3 bromopentane. So you just draw the 5. This is the, and this carbon is your bromine. And a bromocyclohexane, so again you have to draw this hexane. So this is your cyclohexane, this compound, 6 carbon, and put bromine here. So in this structure, if you see, the 2 bromopentane has a asymmetric carbon. So for the condition of optical activity, that carbon must be asymmetric, means all the 4 groups will be different. So in this case, it has 2 hydrogen, so this is cancelled. It has 1 hydrogen, so carbon is asymmetric, so this is correct. But in this case, again the 2 groups is having same, so again this is symmetric. And in this again we have the, if you divide it, the 2 groups are same, so again this is also symmetric. So answer is our B. So in this question, the structure of the polymer obtained by the following reaction. This is a reaction of the styrene, and by using the dibenzoyl peroxide, this catalyst, by heating. So what will happen? So the double bond of this will be split up. So this compound will remain same. If split up means 1 free radical will form this side, 1 free radical will form this side. So most possible answer will be your A answer. So let us see the process also. So this is the process in which you can see how the benzyl peroxide is converting the styrene into polystyrene, that is the polymer. So these are the 2 free radicals. So answer is our A. The major product of the reaction between the sodium ethanoate and CH3 trimethyl CCl in ethanol. So this is your compound. So what is the product? So we have 4 options. So if you see carefully, so this is the tertiary carbon in this case, it is reacting with the sodium ethanoate. So this is a kind of elimination E2 reaction. So what will happen? This is the Cl, and 1 hydrogen will be eliminated out, and it will form a alkene. So we will get this product. So our answer is B. When H2S gas is passed through a hot acidic aqueous solution containing Al3 plus U2 plus lead2 plus Ni2 plus a precipitate is formed, which consists of. So in this 4 ions, only if you see carefully, this copper and lead, this 2 belong to group 2 ions. This 2 belong to group 2 ions, while the aluminum and nickel belong to different group ions. So this will only precipitate, but other ions will not be precipitated. So our answer will be your D, lead sulfide and copper sulfide. The electronic configuration of an element with the largest difference between the first and second ionization energy is. So this is the first ionization energy of this will be very high, and second is 2.5, because this is the inert gas configuration, neon. If you compare with A, this is neon configuration, and if you compare with the B, so this is 3s1, this is for sodium. So first will be your low, but second will be very, very high, because they are occupying the inert gas configuration. In this case, electron is, this is just for the magnesium. So first energy will be a little high, but second will be again low. In this case, again first will be very high, and second is from the 2s2. So they are belong to same subcell, so it will be difference will be again very less. So this is from third cell, this is from second. So definitely that the energy difference between these will be very, very high. So in this case, answer will be your B. The order of electronegativity of the carbon in sp, sp2 and sp3 hybridized states follows. So this is the reaction which is more electronegative. So it depends on the percentage of S characters. So if you see the more percentage S character, it will be more electronegative. So if you see sp, sp2 and sp3, so a percentage of S character in a case of sp is 50%, followed by sp2 and followed by sp3. More the percentage of S character, more is the electronegativity. Other factors are being equal. So in this case, answer is our A. So this is our answer. So again we can see this is most one of the easy question. The most abundant transition metal in human body is definitely iron is present in our blood, copper is less, zinc is less, manganese is very less. So answer will be your iron. The molar conductivity of the HCl, NaCl, and acetic acid and sodium acetate at infinite dilutions follows the order. So to know the molar conductivity, we have to know the individual infinite conduction of each ion. So it is given. So if you see the acetate ion is this much, and sodium is this much, and Cl is this much, and H plus is this pen. Now we'll use the Kohlraasch law of dilution. So to remove what is the conductor of HCl? HCl means so we have to take the H plus and Cl, this one, H plus and acetate ion. So acetate ion is this one, and H plus. So if you add it, this CH3COH and H plus, this one. So on adding, what will happen? So this is nothing but the subtraction. So on subtraction, what happens in HCl? H plus and Cl, acetate plus H plus will be removed. So on adding this H plus and Cl minus, so you can see if you add it, so on adding you will get 425 point this value. Similarly for the acetate, in case of acetate, so this is the acetate one. So in this case, what you have to take this value and H plus value, if you add it, both value, so you will get here 389.7 centimeter square per mole. This is for acetic acid. Similarly, if you calculate for NaCl, this is for Na and this is Cl. If you add it, these two value, you will get this value. And similarly for sodium acetate, you will get this value. So out of 4 value, if you compare it, so on comparison, if you find which is more value, so in case of more value is HCl, and then followed by next is acetic acid, and then your NaCl and sodium acetate. So answer will be your A. So A we can easily see, this is our answer. Molar conductivity at infinite dilution will be this order. The spin only magnetic moment of ZCl42 minus is 3.87 Bohr magneton. So what is Z? So Z means out of 4 element. So first we need to find out the oxidation state of this Z. So if you see the oxidation of Z will be +2 because this is 4 minus 2 will be +2, and number of unpaired electrons will be electrons are 3. So Z2 plus will be how much? It will be D7. 10 minus 3 will be D7. So this is the configuration. So if you see the configuration, it is the configuration of nothing but cobalt. If alpha D glucose is dissolved in water and kept for a few hours, the major constituents present in the solutions are what will happen. So if it is from alpha D glucose or mixture of beta D glucose and open chain D glucose, open chain D glucose, open chain D glucose, or mixture of alpha D glucose. So definitely when you dissolve this, so it will get inverted. It will form two type of glucose. One is alpha D glucose, second will be beta D glucose. So let us see the reactions. The reaction will be like this. On dissolution, this is the alpha D glucose and this is the beta D glucose. So you can see clearly the OH is on this side, so this is beta glucose, and OH is this side is alpha D glucose. So this is an equilibrium position, that is called D glucose. So D glucose is converted into alpha D and beta D like this. So this two will be in equilibrium to each other. So this percentage alpha D glucose is 36% and percentage of beta glucose is 64%. So this is our possibilities are there. The pH of the one normal aqueous solution of HCl, acetic acid and formic acid follows the order. So out of this 3 acid, which is more acidic, definitely HCl mineral acid is more stronger than followed by formic acid and acetic acid. So in this option, you see the strength of acid, so A is our correct answer. The major product of the reaction is that, so this is the option. So this is the dehydration reaction, acetic dehydration reaction of alkene. So we have to form the product. So water will attack on the acid. This pi electron will first attack on the H plus. So let us see the mechanism to understand the answer. So this is the reactant. It is a pi electron will first attack on H plus. So if this attack on H plus, so we will get here H plus charge. And H plus will be at over here because this is the tertiary carbon. Tertiary carbon is more carbocation, is more stable. Now water will attack, so OH will be this side as per the M rule. Markovnikov rule, OH will be this side and hydrogen will be another side. So you will get the OH and we will get the final product, this one. Reaction of aniline with NaNO2 plus dilute HCl at 0 degree centigrade. So at low temperature, this diazotization reaction is take place and followed by the CuCN. So this is an example of your Sand-Meyer reactions, not Sand-Meyer reactions, CuCN. So this is the example of some other reactions. So what will happen? So this NaNO2 will form a, it will attack on the NH2 and it will form a diazonium salt. So let us see how this reaction occurs. So this at low temperature, this will form a diazonium salt, and then after this one, when CuCN will attack, so this will be replaced by the CN and you will get finally this cyanobenzene. So our answer is your third product, that is C. Schottky defects in the crystal arises due to what? So we have four options. So in Schottky defect, actually what happens? It will create an equal number of cations and anions. They will leave the crystals lattice and they will form the equal number of cationic and anionic vacancies. Now this is the second part of the same examination, stage 1. For the reaction, this N2 plus 3X2 will give you 2NX3, where the X is F fluorine chlorine, and the average bond energy of the fluorine NF and the ClCl and nitrogen chlorine nitrogen are given over here. So what is the heat of formation NF3 and NCl3 in kilojoule per mole respectively? So they are asking the heat of formation. So let us see the problem. So you can see minus 226 kilojoule and 467 kilojoule are the heat of reaction. This is not the heat of formation. So they are asking heat of formation, but heat of reaction has been given. So we know the formula of heat of reaction, that is the summation of the heat of reaction of the reactant minus heat of the reaction of the product. So N2 plus 3X2 and 2NX3. So we have to take the heat of the reactant minus heat of the product. It is there. The change of heat of the your reaction is total nitrogen minus products. You can see here heat of reaction nitrogen plus 3 into XX minus 2 into 3 into bond between the nitrogen and carbon. So nitrogen and X, so 1, 2, 3 is there. Similarly, N2 plus 3F2 is this the reaction. So heat of reactant, so this is the N2 and 3F2 and subtracting 2 into 3Na. All values are given. So we'll get values. So this is the heat of reaction of the N2. This is the N2 molecule, and this is the 3 into X2. X2 minus this for the product. So if you put the value, you will get a heat of reaction of this much value. Similarly, for the N2 plus Cl2, this is the product. So again, taking the value. So this is the 941, and 3Cl is 3 into 242 minus 62 NCl. You will get this much value. So these are the two values. So out of this answer, so our answer A is correct. These are our values. The equilibrium constants for the reaction X equal to 2y and Z equal to P plus Q are K1, K2 respectively. If the initial concentrations and the degree of dissociation of Z and Z are the same, so this one Z and Z are the same, so the ratio of K1 and K2 is, so we have to write these two reactions. So two reactions, X is equilibrium with the 2y and Z is equilibrium with the P plus Q. So write the equilibrium concentration. So this is the A minus A alpha and 2A alpha for this one. For this is A minus A alpha and this is the A alpha plus A alpha, since A is the same concentration. So K1 for this reaction will be this value and K2 for this value. Since this is following the 5% dilution formula, 5% dilution formula, so this will be ignored. So K1 by K2 will be this whole value by this whole value. So this is ignored, this is ignored. So ratio will be 4. So our answer is A. The geometry and number of unpaired electrons of M and Br4 2 mass respectively are. So we have to find the geometry. So first we have to find the oxidation state of manganese. So in this case, oxidation state of manganese is how much? So it is 4. So 4 minus 2 is plus 2. So it is filled in the 5 orbitals, you can see, and 2 electrons is removed from the 4s. This is the d5, 3d5, and 4s is 0. Since Br is our weak ligand, so what happens? This will be your unpaired electrons. So Br is the weak field ligand, so coordination number is how much? 4. It will be 4 only. 4 only means it will form the sp3 hybridization. The number of unpaired electrons is how much? 5. So our answer is 3. So it will form the sp3 hybridization, means it is a tetrahedral structures without a lone pair, and unpaired electrons how much is 5. So it is filling only the 5 configuration. 4s is other will be filled by the Cn, sorry, not Cn, Br orbital. So it will be like this. So this is our d orbital, this is 3d, and then next is our one is the 4s, and next will be a 4p. So there will be there. So this is the filled by the bromine, again bromine, again bromine, again bromine. So it will be your sp3 hybridization. The standard cell potential for zinc 2 plus, copper 2 plus, and copper is 1.1 volt. And when the cell is completely discharged, then log of this concentration is closest to. So again, this is the equation of Nernst equation of the EMF of the cell. So let us see how this is solved. So this is the Nernst equation. If you see here, so EMF of the cell is equal to E naught of the standard cell minus 0.059 divided by the number of electron lost, and this is the concentration of zinc by concentration of copper. So this is you have to find out, and the number of the electron lost is 2, and E naught is actually it is 0. So we have to find, because cell is completely discharged, so it is 0, and E of the cell is how much? It is a 1.1 volt. So this will come this side, it will become negatives. So if you solve it, you will get answer 37.3. So answer is our A. So this is the bromo benzene, and we have 3 reagents XYZ and receiving this product. So we have 4 options. So these are XYZ are given here. X is the magnesium triether, Y is this one. So which of these 3 possibilities? So if you see, this is a bromobenzene. So if you use magnesium triether, so it will becomes a Grignard reagent, and if you use carbon dioxide, so it will attack on the carbon dioxide, so it will form this compound. And again, if you give acidic hydrolysis, it will give benzoic acid. So for this we have option C. So C is our correct answer. So C is the correct answer. An organic compound having the molecular formula, this is C2H6O. So this is the formula of alcohol, and undergoes oxidation with the K2Cr2 potassium dichromate in acidic medium to produce X, which contains this compound. X is containing carbon 40% and hydrogen 6% and oxygen 53.3%. So what is the molecular formula of the X? So from this example also it is clear, this compound is an alcohol, so it can be ether also, but alcohol will keep oxidation with K2Cr2, so it will form acetic acid. So most probably formula compound will be your acetic acid, means B. This is the formula of acetic acid. So let us see the mechanism. So this is the ethanol, and if you give oxidation with the potassium dichromate, it forms acetic acid. And if you take the percentage of carbon, hydrogen, oxygen, so carbon will be this percentage, hydrogen will give you this percentage, oxygen will give you 53.3%. That means the answer is your B. The maximum number of cyclic isomers, which includes positional isomers and optical, of a compound whose formula is C3H2Cl2. So C3H2Cl2 means, if you see the degree of unsaturation, so it have a degree of unsaturation is 2, because it will form a alkane C3H4. So alkene C3H4. So H4 means it is a formula of alkyne. So it has a degree of unsaturation is 2. So for 2 means the compound must have one cyclic compound with one double bond. And in that case, we have to find the positional isomers and optical isomers. So let us see the process. Process is, so this is the one cyclic compound with one double bond and 2 Cl. So it can be positioned over here, over this side, and over this side. So this can be go under two cis and trans, and one will be your this one. So one can be your DLN. So this can be optical, this or this. Not this. This is only optical. So it will form two isomer, and it will be one, and it will form. So both are symmetrical. So there is a 4 isomers is possible. This will give you optical isomers, and these two will give you positional isomers. So we have 4 isomers. That is total will be 4. Answer will be C. So this is the volume versus temperature graph of a 1 mole of an ideal gas is given below, and the pressure of the gas in atmosphere at x, y, and z respectively are. So this is the x, this is the y, and this is the z. So this is the, so we have to find the pressure. So for this is the volume, this is given your temperature. So we have given volume and temperature in every case. So we'll use the equation, ideal equation, that is PV equal to nRT. So this is the equation, PV equal to nRT. So we have to find the pressure. So pressure will be equal to nRT by V. So P is equal to nRT by V. So N is actually, it is given 1 mole. R we know that. So we have to take the lesson T by V for each gas. That is Px will be how much, Py will be how much, and Pz will be how much. So let us see the answer. So this is the P is equal to nRT by V, and V is given 50 is in every case. So Px our temperature is 200, for Py temperature 500, and Pz temperature is 200. So on solving we'll get 0.328, 0.82, and 0.82 atmosphere. Means Y and Z both are same atmospheric pressure. So if you see the solutions, we have solution number A. So this is our answer. So this is our Y, and this is Z, and this is for the Px, Py, and Pz respectively. So this is and manganese oxide, dioxide, when fused with potassium hydroxide and is oxidized in air and gives a dark green compound X. So X is a dark green compound. Now in acidic medium, this X solution undergoes disproportionation. This X will undergo disproportionation, and it will give an intense purple compound Y and MnO2. So what is the compound X and Y respectively? So we are given two compound. This is X and Y. So let us see the reaction. So reaction means this manganese dioxide is magnesium, and manganese dioxide is reacting with the potassium hydroxide in presence of air. So it will give you compound K2MnO4. So it is very confirmed. So first product is K2MnO4, and again it is reacting with the acidic medium, means HCl. It will give you again the purple compounds. The purple compound is KMnO4, that is potassium permanganate. So we have two products, K2MnO4 and K2MnO4 and KMnO4. So of this, if you see, the answer will be your this one, answer A. A metal X dissolves both in dilute HCl and dilute sodium hydroxide to liberate hydrogen gas. So if you add ammonium chloride and excess of ammonium hydroxide to an HCl solution of X, so it will produce a Y as a precipitate. Y is also produced by adding ammonium chloride to the sodium hydroxide solution of X. So this is also produced how? By adding ammonium chloride to the sodium hydroxide solution of X. What are the species X and Y respectively are? Now we have to react this X with these two different compound to liberate hydrogen. So we'll see this one. So when zinc is reacting with the sodium hydroxide, so we have to look in the opposite. We have two metals, one is aluminum, second is zinc. When zinc reacts with sodium hydroxide, it will give you sodium zincate, and same with HCl, it will give you ZnCl2 plus hydrogen. Similarly, aluminum with sodium hydroxide, it will give you sodium aluminate, meta-aluminate, while aluminum in HCl will give you hydrogen gas. So aluminum giving hydrogen gas with the both aluminum and zinc with they are giving H2 plus O2, and but with US they are giving these two product. So in this product, so zinc Cl2 when reacting with the zinc Cl2 will not give precipitate when reacting with the ammonium chloride and ammonium hydroxide solution. Now we left with the aluminum hydroxide. So aluminum chloride. So this aluminum chloride will give you gelatinous white precipitate of aluminum hydroxide with ammonium chloride and ammonium hydroxide. So this will give you precipitate, but this will not give you precipitate with this compound. So we have X and Y. So X we have aluminum, and second it is giving precipitate, white precipitate, so it will be aluminum hydroxide. So zinc is not possible. So out of the two metals, only aluminum is possible. This is giving precipitate also, this is also giving hydrogen.